Hi everyone. So in today's video we will be talking about the third topic of object-oriented programming, which is called polymorphism. So what is polymorphism? So polymorphism has mainly two terms. The first term is poly, the second part is morph. What does this mean? This is originated from a Greek word where poly means many and morph means form. So basically polymorphism means something that has many forms. For example, think about this pen. We all have used such pens in our childhood, right? This is a single pen, but the same pen has multiple colors. It has a black, red, blue, green, orange, and purple as well. It depends on which switch you press. If you press this switch, it will be orange. If you press this switch, it will be green. Depending on which switch you press, it will take its form. It is the same thing, but it has many forms. So it is one of the examples of polymorphism. Okay, take this toy. You have seen this toy many times. This is a Transformers robot, right? So Transformers robot can be a robot, right? But it can also change its form into a aircraft, and it can also change its form into a tank. It depends on how on what you do with it, but it has many forms, multiple forms. Similarly, you have multi-purpose tools. For example, this hammer axe kind of a thing, which can act as a hammer, it can act as a plier, it can act as a hatchet or a knife blade, wire cutter, a wrench, wood saw, screwdriver, nail file, bottle opener. So the same thing has many forms. This is what is basically known as polymorphism. These are the real life scenarios. Now we will look into the programming scenarios of polymorphism. So anyway, we will go into it. Before that, understand there are two types of polymorphism. The first type is called the static polymorphism, where the compiler is aware of what's going on and what will be happening in the future. Basically, this is also called compile time polymorphism, static polymorphism or compile time polymorphism, or it can also be called as compile time binding as well. Okay, compile time binding, you can call it like that. And the second type is dynamic polymorphism. Compiler is unaware, compiler doesn't know what's going to happen. It will be only known during the runtime. Okay, this is dynamic. This is called dynamic polymorphism or runtime binding, whatever you like to call it. So the static polymorphism happens in the Java compiler, Javac, and dynamic polymorphism happens in JVM. If you remember how Java works, so we write the source code, then we compile this using what? Using the Java compiler, also called as Javac. This is where static polymorphism is already known. Okay, that this is going to happen. This is called static polymorphism. The compiler already knows. Then this compiled code goes through JVM. This is where basically this compiled code is a bytecode, right? This is a bytecode. Bytecode gets executed by the Java virtual machine, also called JVM. This is where the dynamic binding or runtime binding happens. Basically, dynamic polymorphism happens. Now, these are the broad types of polymorphism, and we will be looking into first things first. Constructor overloading. We have already done constructor overloading during object-oriented programming part 1. If you haven't seen this video, just check out the constructor overloading part. I have mentioned the timestamp over there, so you can check out that one, but I'll also be showing here as well. Then we will be looking into method overloading, which is another interesting thing, and we will finally look into operator overloading, which is, by the way, not allowed in Java, but as you know, I'll be taking an example of Python to showcase what's operator overloading and how does it work in other programming languages, just so that you have the basic idea of what operator overloading looks like. Finally, once we are done with these things, we are done with static polymorphism, then we'll move on to dynamic polymorphism. In dynamic polymorphism, we'll be looking into method overriding. There's only one type of dynamic polymorphism, that is method overriding. We'll look into that. So first, let's start with the first thing, which is the constructor overloading. So constructor overloading, I have already shown you this one, but let's go through it once more, right? So say student has multiple constructors. Okay, a student has multiple constructor. Say this is a parameterized constructor. Then, like the normal constructor that we define, right? It will take a name from the user, the roll number from the user, and the standard where the student, like in which class does the student studies it, right? It will take it from the student, like from the user, and it will make an object. Okay, and then you have another constructor. See, constructor always have this thing that every constructor will have the same name as the class name. Okay, if a method has the same name as the class name, it is considered a constructor. So you can see there are multiple constructors in the same class, right? And this is a copy constructor. Okay, this makes copies of other, like of its own object, and creates a new object. How does it work? Well, go check out the first part of object oriented programming, where I explained how copying works, copy versus reference and everything. So I'm not going into detail. So depending on how you call the constructor, one of them will get triggered. For example, if I say you're creating a new student, S1, and you call the constructor like this, you pass in the constructor, you basically call the constructor and pass in the name, the roll number, and the standard. So which of them is expecting a name, roll number, and standard? Is it this one? No. Is it this one? Yes, it is expecting a name, it is expecting a roll number, and it is expecting a standard. You are putting all these three. So which one will get called? It's a no-brainer. Of course this will get called, right? In the second line, you are creating another object called S2, and you are saying new student, and you are passing just a copy of, like, just an object. Say this is a student object, you are passing a student object. Now which of them is expecting a student object? Is it this one? No. Is it this one? Yes, it is expecting a student object, and you have passed it. So which one will get called? Again, it's a no-brainer. This will get called. So although you are calling the constructor, depending on, now listen to my words very carefully, depending on the arguments, or say the parameters, or depending on the parameters, one of them will be triggered. Okay, this is constructor overloading. Let's see this in action. Let's quickly open BlueJ first. Okay, let me do this. Let me delete all these things. I don't need any of them at the moment, at least not at the moment, right? Just delete this. Delete. Okay, all deleted. Entry point, let it be there, because we need an entry point, right? Let's create a new class. Let's call it the student class. I am creating everything from scratch so that you you know, it gets on your head, right? How to create classes and objects, right? So anyway, we have this student class. Delete everything over here. And now you need a constructor. Say you will take a name. Okay, let's say the student has some name and all. Let's define some properties. So say the student has public string name, public int role, and public short, or public maybe byte standard, or you can just simply say int, doesn't matter. I was just trying to write efficient code. Public int roll and standard, or just say std, that's it. So it has a name, a roll number, and a standard. Cool. Let's create the first constructor. Parame parame oops. Okay, parameterized constructor. Okay, let's create a parameterized constructor quickly. You can say public student. You like, it's your choice, you can put public or not. You can remove the public keyword as well, but anyway, student. It will take in three things. It will take in the name, and yes, better to add an underscore just to differentiate between the arguments and its own properties, attributes, right? So int role and int standard will take these three things, and over here it will just assign the values. This dot name is equals to name, this dot role is equals to uh, role, and finally this dot standard is equals to standard, and it will finally print out system dot out dot println. Maybe I'll just print out the name, this dot name, um or maybe I should say something like this: student, this dot name, whatever the name is let's do it a full screen. Studying in whatever the class is. This dot std with roll number, whatever the roll number is, this dot roll is created. Okay, done. Cool. So we have this parameterized constructor, and then let's create a copy constructor as well. Oh, I forgot a bracket. Thanks for reminding. Okay, let's create a copy constructor here. Copy constructor. Public, again, student. It won't take anything. It will just take its own object. Student s1 and it will just make a copy of whatever, not the s1, I should say, I should just write a name, I mean obj or whatever, you can write whatever you like. So just come down here and say this dot name is equals to whatever is the name of object, this dot role is equal to whatever the role of the object is, and this dot std is equals to whatever the standard of object is, and just print out the same thing. Say that you have created a copy of student. Yeah, so this is the copy constructor, and just say, also say this system.out.println, just say copy constructor called, I mean just for better clarity. Okay, so these are the two things. Let's compile this. Let's make sure things are good. I'm not creating any other methods, not required at the moment. I'm just trying to show you the constructor thing at the moment. So let's, yeah, close it out. Let's go to entry point. Of course I need to delete all this stuff and simply create the student object first. Student s1 is equals to new student, um I am not good at finding names, so let's call it Vivek, and roll number 12, and maybe standard is 4. Yes. Okay. And then let's create another student S2, which is a copy of S1. Copy of S1. Okay. How do I make a copy of S1? I call the copy constructor. And how do I do it? I call the same constructor but pass in the student object S1. So this will not call the first constructor. This will call the second constructor, which is the copy constructor. Okay. This will create a copy of S1. Okay. Let's try compile this. Everything compiled. Let's try and run this. Okay. So what is happening? Student Vivek studying in class 4 with roll number 12 is created. That's perfect. Then what happening? Then what's happening? Then copy constructor is getting called. Copy constructor is getting called. So it is just showing copy constructor called. Copy of student Vivek studying in 4 with roll number 12 is created. So we are calling different methods. We are calling different constructors but using the same constructor name, right? Look at this carefully. Here what I am doing, I'm saying student Vivek 12 4. So basically I'm creating an object called like a student object having Vivek as the name, 12 as the roll number, and 4 as the standard where he's studying. Okay, this is the constructor. This is the parameterized constructor that is getting called, which is basically this one is getting called, right? This one is getting called. Perfect. But whenever I switch to the next line, which is basically calling the copy constructor, this is not calling this, is not calling this. This is rather calling this. Although both has the same name, student, but it is depending on what you are passing. If you are passing name, roll number, and standard, it is going to call this one. If you are going to pass just a student object, it is going to call copy constructor. And if you pass some other thing, it is going to show you error. Okay, so in the second line, whenever you call the copy constructor, you can see copy constructor called, like I had written, right? I had written over here that whenever this is called, it will print it copy constructor called. So it is getting called, and then it will show up copy of student, whatever the name is, studying in whatever the standard is, with whatever the roll number is. So it is perfectly working fine. Now you might ask, can I have multiple parameterized constructor? Yeah, you can have. Let's create another constructor. Let's see what happens. Parameterized constructor 2. Let's create another constructor. How do I do it? Public student. Let's for the sake of argument say this only takes name. That's it. It doesn't take anything else. What happens then? What about the roll number and standard? Oh well, you can keep it undefined, or you can assign some auto value. Okay, say this dot. Hold on. I can use math library to do some auto things, right? I can import the math library. Java import java dot lang dot math. Let's import the math library and go there. And before you do that, let me show you how we generate random numbers. So this is Java JShell. Let me show you how we generate random numbers so that you don't have any doubts regarding that. Although math library will itself be a topic, but let me show you quickly. Import. So math library has a ton of math features. And you import it like this. Once you're done, so this is like a math class which is written by someone else, and you're just using its functions that are defined. So one of the functions that math has is called random. This is a static function, of course. That's why you are typing in the class name and you are calling the random function, right? Now you know why you write the class name and then you put the dot and you then call the function name, because this is the static function. And what does it do? It gives you some value from 0 to 1, some value. I mean 0.1 to 0.9 something something. Every time it will give you a different value. Every time it will give you a different value. So how can you generate random integers? Because of course, as you can see, this is a double. This is a double. This is not even a float number. This is a double, because it is going very long, right? It's very long after the dot, so it's not float, it's a double number. So can you do something to convert it into integer? Yes, of course. This is of course going to give you 0 to 1, right? Nothing more, nothing less. So how can you make sure that it is giving you some random integer? Well, what you can do, whatever random number you are getting, say 0 0.1 2 3 4 whatever, just multiply it with whatever number you wish. Like this is going to be the maximum number. So once you do this, you will get any value from 0 till 100. You can get anything. Let me show you. If you multiply this with 100, you will get 97. If you try doing this again, 21, 9, 28. But there is another problem. This is still in double. Although you are multiplying integer, this is still in double. And roll number, standard cannot be in double, right? It has to be in integer. So you can typecast. You can typecast. You can convert the double into integer and then 100. But it is going to give you 0. Why? Why so? Because whenever you're typecasting only this part. Only this part. The problem with this is that when you're typecasting into integer, it will only take whatever is before the dot. This is the dot. Whatever is before the dot, integer will take that. Problem is that whenever you're calling math.random, just this thing. Again, let's call this. What are you getting before the dot? What are you getting before the dot? 0. You're getting a 0. If you just call this, you're getting a 0. Correct? So when you convert it into integer, what are you going to get? Of course a 0, because it is going to take whatever is before the dot. It is going to give you 0. Now 0 into, doesn't matter whatever you do, into 1000, it's going to give you 0. This is not the right one. Instead, what you can do is that first you do math.random, you multiply it with 100 or whatever you like, you will get some random number which is a double number. Now take the entire thing, listen to me very carefully, take the entire thing into a bracket. Now typecast it. Now typecast it. So it will typecast not just this, it will typecast the entire thing. After multiplying, first it will multiply a random number and 100, it will give you some number, then you will convert it into integer and you will get the 31 part, I mean whatever is before the dot part. So in this case 98, if I call it 95, 4, 37, so you're getting the random integer. So we'll be using this only. Let's just copy this thing and let's just use this for roll number and standard, right? So where were we? So we imported the math class. Yeah, so the user will give the name, no doubt, and we will put it like that. And yeah, let's put an underscore before this just to differentiate. So this dot name is going to whatever the user is putting, but the roll number is going to be some integer, some random integer. Let me just put it like this, some random integer. And let's make sure that this roll number has to be of course something like, say for example, maybe up to 50 is the range, no roll number before 50. Okay, and this dot standard is equals to, again the same thing, but standard can be up to 12, right? There are only 12 classes, so oops, so standard can be up to 12. Will this work? Of course this will work. Let me show you. Let's go back to JShell, clear all this. Oops. Yeah. Yep, it is working. 9, class 1, class 9, class 2, class 0, 0 means primary or pre-primary. Think about it. Okay. Yeah, perfect. Okay, okay, it's working fine. So it will assign some random class, and it will, I mean, standard, and it will assign some random roll number. Can I have a parameterized constructor, another parameterized constructor? Can I do this? Look at this, look at this. We already have a parameterized constructor. We are creating another parameterized constructor. Of course, it is taking different parameters. That is why it is constructor overloading, right? So let me, just for differentiating factor, let me do this. System.out.println, and let me say param, I'm not writing the entire thing, param constructor 1 called, and for this one I'll just say parameterized constructor 2 called. Parameterized constructor 2 called, and I'll just pi to pi copy this, maximize this, copy this, paste this. Okay, okay, this is going to be random. Okay, whatever the standard and the roll number is going to be random. Okay, so yeah, let's compile this. This is good. Let's go back to the entry point. So this is of course going to create a copy of Vivek. Let's create another student. Let's say student S3 is equals to new student, and let's just pass the name. Let's say Kanika. Let's say Kanika. Okay, just pass this. We are not passing the roll number and the standard. So what will happen now? Let's compile this and let's run it. Just delete all these things. Yep, yep. Oops. Go back. Okay, so what is happening? What is happening? Let me go back to the code once quickly. Look at the code. So first you are saying student S1, new student. You are passing Vivek's roll number and the standard, and this is going to call the first parameterized constructor. You can see parameterized constructor 1 called, and you are creating a student Vivek studying in 4 with roll number 12. So this is basically calling this one, this guy over here. Okay, you're calling the first constructor. Okay, what about the second line? Well, this is you are calling the copy constructor. It is creating a copy of Vivek. Okay, you can see copy constructor called, copy of student Vivek studying in 4 roll number 12 is correct. So you're basically creating a copy. So this is calling which constructor? Not this one, not this one. This is calling this one, this copy constructor. It is getting called, right? This you know. Okay, okay, what about this one? What about this one? Student Kanika. You're just passing the name. You're just passing the name. So what exactly is happening? Which one is getting called? Is it expecting just a name? Nope, it is expecting a student object. Is this expecting just a name? Nope, it is expecting name, roll number, standard. Is this expecting name? Yes, this is only expecting the name. You have passed the name Kanika. It will set the name as Kanika, but the roll number will be random. The standard will be random. Let's check. You can see in the third line, whenever we are just passing in Kanika, we are calling the second parameterized constructor, param constructor 2 called. You are creating a student called Kanika who is studying in class 8 with roll number 16, but you haven't passed class 8 or roll number 16. You haven't passed it. So of course it is basically a random integer, and you are creating this random integer using this math library. You are setting a random integer to the roll and the standard. That's how you are creating a student. So you can, yes, the answer is yes, you can have multiple parameterized constructor, you can have multiple copy constructors. Basically you can have as many constructors as you want. I don't know what will be the reason for doing so, but yes, you can do that. That is technically possible. although the use cases are very limited for that. Anyway, let's go back. So yeah, we are done with constructor overloading. So for constructor overloading, the final conclusion would be you can have as many constructors as you want, as you want. Okay, be happy with it. Let's move on to the next part, which is method overloading. It is the exact same thing, but in this case it's the method, not the constructor. You can see what is happening here. I have defined four methods with the same name. This method is called div, this method is called div, this method is also called div, and this method's name is also div. So you have multiple methods, okay, but with the same name, and depending on what you pass, basically depending on the parameters, one of them will get triggered. For example, let's take this thing. You have passed only two integers. 10 and 5. Which one of them is expecting two integers? This one? No, this is expecting three doubles, not this one. This is expecting three integers, not this one. This is expecting two double, not this one. This is expecting two integers, so this one will be called. Okay, when you are passing two integers, which one will be called? This one will be called. You will get some answer. Okay, you will get some answer. What about the next one? You're passing two double. 16.3 and 2.6. Which one will get called? All of them has the same name. Which one will get called? This has two double, this has three double. This is expecting three integers. This will not get called. This is expecting two doubles, so this will get called. You are passing two doubles. This is expecting two doubles. This will get called. What about this one? You are passing an integer, another integer. So you are calling a method which is expecting three integers. Which one will be called? This one. Why? Because this is expecting three integers: integer 1, integer 2, integer 3, and you are passing first integer, second integer, and third integer. So this one will be called. But what about this? You are passing three doubles: 100.6, 2.6, 3.11. Which one of them is expecting three double parameters? Of course this one. So this will be called. So depending on what you are passing, depending on the parameter that you are the argument that you are passing and the parameter it is expecting, one of them will get triggered. Okay, this is just a dummy class that I have created, my math class something, and let's see this in action quickly. Let's go back. Okay, let's play around the student for a while. Okay, let's say our student class, and let me clear this, by the way. Let me just close this one. Yeah, say our student has all these constructors. That's great. Let's create some methods as well. Okay, so let's create our first method. Say public, and let's create a non-static method first, because let's say eat. Public void eat. The student wants to eat something and it does not accept any parameter. Let's make a method like this. It does not accept any parameter and it just says system dot out dot println student eats. What? Nobody knows. Nobody knows. Okay. And also passing yeah, okay, this is the first method. Let's create another method, public void eat. This is expecting you to pass a food or something. Okay, and this will say system dot out dot, actually, you know what, not student eats, rather I should do this. This dot name is eating. What eating, I don't know, but in this case you would say this dot name is eating and the user is passing the food name, so just put in the food name. Cool. And let's have another method for this. Public void eat string food1. Let's say this guy eats two things at a time. Okay, this dot name is eating food1, whatever the user passes, with food2. Okay, so we have three methods. With the same name. This is also it, this is also it, and this is also it. But where is the difference? Difference is the list of parameters. This guy is expecting nothing, this guy is expecting only one parameter, this guy is expecting two parameters. And yeah, by the way, these matter, these do matter, the data types do matter. Okay, so let's have another method, public void eat, just to showcase you that data types do matter. Int number or int quantity. Say the guy is eating 5 rotis. Quantity and string food. And this time you would say system.out.println this dot name is eating whatever the number is. I've say 5 rotis. How do you put it like that? Quantity plus some space and the food. That's it. So you have 4 methods with the same name. Say I'll call this eat1, I'd call this eat2, I'd call this eat3, I'd call this eat4. Let's say we have 4 eat methods of student method. Okay, let's compile this. This is compiled. What about the entry point? Let's remove all these unnecessary things. We're done with these things. Okay, let's say we have Kanika. Okay, let's say Kanika. Let me remove all these things. Cool. Now what will Kanika do? Kanika will first eat. She won't do anything else. Okay, she'll just eat. What she's eating, we don't know. What about s3.eat? Just one food, say pizza. Okay. What about this s3.eat? Noodles or maybe momos, soup. 2 foods, right? You remember that method? And finally s3.eat say 5 roti. Just say rotis. All right, let's compile this quickly. And yeah, I need to take a few screenshots after this, but let me just first quickly run this. Okay, what is happening here? First of all, parameter constructor 2, parameterized constructor 2 is getting called, of course, because if we go back to the code, we're just passing the name. Which one of the constructor it is just expecting the name. Of course, not this one. This is expecting 3 things, not this one. So which one is just expecting one string parameter? This one. So yes, this is getting called. Your Kanika is getting created. The roll number and the standard is, of course, it is a random number. And yeah, parameterized to constructor is called and the student is created. This is what we have, what we already know. Parameterized constructor 2 called, student Kanika studying class 3 with roll number 22 created. This is random all. Okay. Now, very importantly, when I say s3.eat, which one is getting called? Which of the eat method is not expecting any parameter? Any parameter. I'm just calling just eat. I haven't passed anything. Which one will get called? Yes, eat one will get called. Why? Because it is not expecting any parameters. Okay, this does not have any parameter, and you are just saying s3.eat. So this will trigger, and it will show up the name and will show is eating. So you are seeing Kanika is eating. Great. What about the next line? S3.eat pizza. One food. You are just passing one food. Which of them is expecting only one food? And I mean only one string parameter. This one. This is expecting only one string parameter, which is food. So this will show up the name and what she is eating. So Kanika is eating pizza. Why so? Because you have passed pizza and her name is Kanika. So Kanika is eating pizza. Great. What about the third line? Third line. S3.eat momos and soup. You have passed two string parameters. Which of them is expecting two string parameters? This one is expecting two string parameters. Both are strings. So it is expecting two string parameters. You have passed momos and soup. This will show up the name, what she is eating, and the other food name. So you are seeing Kanika is eating momos with soup. Are you getting this? Kanika is eating momos with soup. So which one is getting triggered? The third eat. Eat 3 is getting triggered. Great. What about the last line? S3.eat 5 comma rotis. So which of them is expecting one integer and one string? One integer and one string. One integer and one string. So this will get triggered. Eat 4 will get triggered. It will show up her name, how many she is eating, and what she is eating. So her name is Kanika and she is eating 5 rotis. Why it is showing up so? Because you have said 5 comma rotis. So this method will get triggered and it will show up Kanika is eating 5 rotis. So this is exactly how method overloading works. All have the same names, but depending on what you are passing and what it is expecting, one of them will get triggered. Okay. Great stuff. Let me just quickly you know summarize this thing. Let me just quickly summarize this thing. Let me copy this one. This is too big of a thing. Can I copy this? Can I really copy this? Okay, let me try this. Okay, too big of a thing. Can I squeeze it a little bit? Yep, I guess this works. Yeah, well, looks good. So let's go back once again. Let me go back over here. Entry point. Copy this. Paste it over here. Okay, and the output box I will also Try to copy the output box. Okay, let's see what's happening. So let's take the red line marker. Yeah. So line 1, student S3 is getting called. S3, you're just passing one. This constructor, you're just passing only one string parameter. Which constructor is expecting only one string parameter? This one. It is expecting only one string parameter. So of course this is getting called. Okay, your name is getting fixed. So yeah, parameter 2, parameter constructor, parameterized constructor 2 is called. You're seeing at this. And then Kanika, you have already mentioned her name. So Kanika, studying in 3, this is a random number. Sorry, this one. Studying in 3, this is a random number with a roll number 22. This is again a random number. Is graded. Okay, good. This part is done. Second line, s3.eat, no parameters passed. Which one is getting called? This one. No it is expecting no parameter. So Kanika is eating. Kanika is eating, right? This one. Okay. What about the next line? s3.eat pizza. You are passing just only one parameter, one string parameter. Which one of them will get triggered? This one. Why? It is expecting only one string parameter. This one will get triggered. So it will show up Kanika is eating pizza because you have passed pizza. Passed pizza. So Kanika is eating pizza. Okay, this is also done. What about the next line? Momo soup. Two string parameters. Which one of them is expecting two string parameters? This one. This one is expecting two string parameters. So of course this will get triggered. Eat3 will get triggered. It will show up Kanika is eating momos with soup. Kanika is eating momos with soup. This is also done. The last line, s3.eat 5 rotis. So one integer parameter, one string parameter. Which one of them will get triggered? Of course this one. Why? One integer and one string. One integer and one string. So this will get triggered. It will show up Kanika is eating whatever the quantity is. That is 5 rotis, right? Oopsie. That is 5 rotis, 5, and food, that is rotis. So it will show up as Kanika is eating 5 rotis. So this is method overloading. Okay, depending on whatever your methods are expecting, one of them will get triggered. Some other example of method overloading would be this one. Let me just quickly show you this. Let's create a math class quickly. Oh, by the way, if you have understood the concept, you can skip. Or just let's call it my math, probably. Yeah, my math. And we'll create some static methods now. We have created non-static methods. Now we'll create some static methods. Static, yeah, my math. Let's remove everything. No constructor required. Just say public static. We'll return a double. Return a double. Div integer x and integer y. It is just expecting an integer x and y. It will return, of course, it will return x by y. Okay, this is done. Similarly, just copy these things. But you will say that we can have multiple methods, right? With the same name. So why is it showing error? Because yes, you can have multiple methods with the same name, but the parameter list should not match. In this case, you have already defined a div method which is already expecting two integer parameters. And you are again defining a div method which is expecting again two integer parameters. and you're again defining a method which is div method which is expecting two integer parameters. So this will not work. This will not work. This is the reason you can see method div int is already defined. You cannot do this. So what about you can change this to a and b? I mean, say a and b. Will this work? It will still not work. It will still not work. Why? Because hey, come on, you are just renaming the variables, but it is still expecting it is still expecting two integer parameters, which is already been defined over here. You're already expecting two integer parameters over here, and you are again defining the same method with again two integer parameters. Doesn't matter what the name is. Doesn't, you can put it whatever you want to, a b c d, whatever you can do it, but you cannot have same method with the exact set of parameters. Cannot have. Yes, you can have something like this, double and int. It will not show any error now. It will not show any error. Why? Because the signature is different. It is expecting two integers. It is expecting one double and one integer. Rather have both doubles for that matter. Yeah. Okay. You can have multiple, I mean, say x, y, z. Let's have another z, int z. You can have this. This will not show any error. Oh, sorry, this is a and b, right? Let's call it x, y. Yeah. Otherwise, this was mismatching, right? And of course, you can have double x, double y, double z, double x, double y. In fact, I want to show you something. If you just copy paste this, see, this is happening again. If you do this, it will show you again that hey, you already have a div method which is expecting three integers, and you are defining another div method which is expecting another three integers. Doesn't matter what the name is. If even if you say abc, they are still three integers. You cannot do that. You must have different set of parameters. Or if you really wanna do that, uh, see, this is not allowed. This cannot be allowed. This is already over here. Yeah, you can do something like this. Rather int a, and this will be correct. Why? Because it is a different setup. This is expecting three integers. This is expecting four integers. This is correct. No issues in that. But this cannot be allowed. You can do something like this. Double. You can do something like this. Double. And do something like this. Double. Or you can put some int over here. Even that is okay. But the main point is that you cannot have the same signature, same method with the same name that is expecting same type of or same number of parameters, right? In this case, double, it is expecting three parameters. Yes, it is expecting three parameters. That is not wrong. Why? Because it is expecting three integers, whereas this is expecting three doubles, or maybe one double, two in, two double, one in. It doesn't matter. It has to be different. So that is what my point is, and you are done. Okay, you can go up over here, remove all these things. By the way, you don't need to create a math class to call these functions, because all these are static functions, like static methods, so you don't need to create the math object over here. You can directly call it mymath.div 5,2, and you can also say mymath.div 10.2 comma 45.78. You can do all these random things over here, and you can simply say system.out.println system dot oops system.out.println, and this will work. This shall, oh, what did I do? Did I do something wrong over here? Oh, some bracket issue, lol. Yeah, okay, good. Let's compile this. Okay, let's try and run this. Oh, this is not yet cleared. Let me call this again. Not this. So 2.0, of course, 5 by 2 gives you 2.0. And yeah, this one 10.2 comma 45.7, it is giving something. So depending on what you are passing, one of them will get read. For example, 5 comma 2, both are integers. Which of the methods are expecting two integers? Of course, this one. Which of the methods are expecting uh, uh um three, like two doubles? This one is expecting, so this will get triggered. Yeah, I'm sorry, I need to do something like this as well. X divided y divided z, something like this. Yeah, because there are three parameters, right? Yeah, compile this now. Good. So yeah, if I pass something like this, say, let's copy this up. I'm getting tired. Let's say 13.12.34. Let's compile this and let's clear this out and run this up. Yeah, so you're getting something. So you're passing three double values. So which one of them will get triggered? This one, because this is expecting three double values. What about this one? What if you pass some weird thing, say 10.2 comma 5? So you are passing one double and one integer. One double and one integer. What will happen now? Compile this and let's run this. Let's run this. Still it is working. But the question would be, I haven't defined any method that is expecting a double and an integer. 10.2 is a double number, 5 is an integer number. So I haven't defined any method that is going to make this work, right? So which one is getting called? You're confused, right? You're confused. Which one of them is getting called? Because this is a double, this is an int. There is no method that is expecting an integer and a double. They are expecting int, they're expecting double, they're expecting three ints and three doubles. But where is one double and one int? That's a nice question. To show you which one is getting called, let me just print out div1 called. Let me just copy paste this thing. Div2 called and div3 called and div4 called. So which one of them is getting called? Let's try to see. Let's compile this again. Let's create the screen. Let's compile this one as well and run this. Let's see what's happening. Div1 called. Of course, this will call div1 because two ints. Of course, this will call div2 because two doubles. Of course, this will call div4 because there are three doubles. But what about this? One double, one int. Which one is getting called? Div2. What is div2? This one. But you will say, hey, I have passed a double and an integer. Why is this getting triggered? I haven't passed a double. I have passed a double and an int. Well, my friend, 5 is an integer, right? And if you have gone through all my lectures, you might recall there is something called widening and narrowing. You remember explicit typecasting and implicit typecasting? So basically the thing is that integer is smaller in size than double. right? Integer smaller in size than double, correct? That is the exact reason when you are passing integer, it is getting converted into double. Why? Let's see this. Let's see this. This is interesting, isn't it? So what is happening over here is this. This is your double. This is expecting double, and it is expecting another double. This is your div2. This is your div2. So you are passing 10.2, which is filling the entire box, and you are passing, say, 5, for example. This is an integer by default, of course. Of course, this is an integer. But I haven't defined any method where it accepts integer. Like, I haven't defined a method which accepts double and an integer, right? So the compiler will search for something that is at least bigger than this. Like, I haven't defined this and I am passing double and something, so this one will get matched. The second part is not double, so it will convert it to double. What's the big deal? It will just put a 0 behind it. It will make a double. It will become a double now. It is just converting this, and thus div2 is called. Thus div2 is getting called, which is expecting a double double. Is expecting a double double. This is called implicit typecasting. Okay, there is no definition where it is expecting a double and an integer. So what are you doing? You are doing double and you're passing integer. This integer is getting converted into double, and then div2 is getting triggered, which is expecting double double. This is the magic of method overloading. So you would ask, what if I define something? What if I define like I specifically say that I have a div method over here. Say, I'll just copy this. Okay, this is not allowed, but I can say something like this. What if I explicitly say, is this allowed? Yes, this is allowed. Let's call it div5. Now what will happen now? What will happen now? Let's clear the window. Let's compile this and let's run this. Now div5 is getting called, because I have explicitly said that there is a method that is expecting a double and an integer. But if the compiler cannot find this now, then it will look for something which is bigger than this. Now double fits the window of double. Yes, of course, double fits the window of double, but double also fits the window of int. Correct? That's how method overloading works. One more thing about method overloading is that, let me delete this and show you. Okay, so this is correct, all right, and this is also correct. Okay, this is also correct. Yeah, of course. I mean, the return statement should be like this. Take the entire thing and then typecast it into integer. Yeah, okay, this is also correct. What is not correct is that, see, method overloading, Java compiler does not care. Java compiler does not care about your return type. You can have multiple methods with the same name, with a different set of parameters, and with a different set of return type as well. Okay, but important thing is this: if you try to define something like this, public static, say, let's even do this double. Sorry, public static, say double div, and say this accepts int x into y, and yeah, it basically returns x by y. Is this acceptable? No. What does it say? It says method div int is already defined. Method div int. So do you see what it cares about? It doesn't care about your variable names x or y. You can put a and b, c and d, whatever you like. It doesn't care about that. It also doesn't care about your return type. For example, you might think that if I change this to int, voila, this is done. But sorry to disappoint you, this is not gonna happen. Even if I do this, this will still say diff int is already defined. Although you might argue that, hey, but this is a different method, isn't it? This like the return type of this method is double, and the return type of this method is int. So aren't they two different methods? No, sir, that's not the case. Why? Because the compiler doesn't care about its return type. The compiler only cares about the name and the parameters. In this case, we have already defined a method which is expecting two integers. We are again defining the same method with the same name that is expecting another again two integers with the same name. This is not allowed. Doesn't matter if even if you do something like this, string or something, this doesn't matter. Here's the point. Okay, so the return type can be anything. Method overloading is unaffected by that, but make sure that this part is different, otherwise this will not work. Doesn't matter even if you put something like this long or something like this will still not work. Why? Because of the signature. This is expecting two integers, this is expecting two integers, it will not work. The moment you do something like this, int z or something, this is okay because it is now expecting three integers, it is expecting two integers with the same name. So the main point is that the Java compiler doesn't care about if there is a method overloading thing. The Java compiler doesn't care about your return type. There can be double div, there can be long div as well, but the set of parameters should be different, must be different, otherwise you will get a compilation error. So yeah, that is all about method overloading. Now we'll be moving on to something called as operator overloading, which is not allowed in Java. So we will be looking into this using Python. Okay, so our next topic would be operator overloading. Now technically operator overloading is not allowed in Java, but it is a part of polymorphism and it is used in certain languages. So for the sake of completeness, I'll show you what operator overloading is and why it is used in certain programming languages. Let me quickly check. Yeah, things are good. So let me show you what is operator overloading. So say there is one x variable, int x variable, and there is another int y variable. X is 10, y is 20. You know, if you add both of them, what you will get. 10 plus 20, of course, 30. Right? Common sense. But let's say you have a student. Let's say you have a student object. Say s1, and you have another student object, say student s2. Okay, you have two student objects. Student s1's name is say Vivek and say student s2's name is Rahul. Great. And let's assume that the student has another property. So this is the name property. Let's assume that the student has another property called marks. Okay, so this is name and this is marks. So say Vivek got 20 and Rahul got say 40. So this is s1, this is s2. My point is that when you add two integer variable, what you will get. When you add two double variable, what you will get. For example, if I say for example you have a double a 10.2 and you have a double b 1.2. if you add both of them, what you will get? You will get 11.4, correct? 10.2 plus 1.2, you will get 11.4. But what if I say that you have a student s1 and you have a student s2. Okay, and you add both of them, you say s1 plus s2. What will you get? What will you get? You cannot do this because nobody has defined. I mean, student is just an object with a name Vivek and marks 20. Student S2 is just an object with a name Rahul and a marks of 40. What are you expecting? Nobody has defined that, right? Even if you add both of them, nobody has defined that what you will get. In this case, I know what to do, but in this case, I don't know what to do, right? I'm not really sure what to do. Defining that, defining, defining. So basically, defining what this will do is called operator overloading. Okay, which by the way is not allowed in Java. You cannot do this technically in Java. Okay, it is allowed in certain programming languages, say Python and C++. So I will quickly go to Java for the sake of completion, and let me open BlueJ quickly. And yeah, of course, let me delete this. Okay. delete. Okay, cool. We have the student. We already have defined all these things. Let's ignore this for a moment, and let's delete all of these things for the moment. Okay. Um. Yep. Let's also delete this as well. And for the time in, say student will have only two properties, name, and student will have marks. Okay, just these two property. Let's define a constructor, student constructor. This will take a name, and this will take marks. Okay, all right. And of course, this will assign the name to name, and this will assign the marks to marks. Okay, whatever the user gives. Cool. And yeah, honestly, it will just show up as system.out.println student this dot name, and just say created. That's it, simply a student this created, and basically that's what you're getting. Okay, and that's it. Let me save this, let me compile this. We are good to go. Let me go to the entry point and let me remove all of these things. And let me just create a student, create two students. Let's say student s1 is equals to new student the Vivek. We'll be using the examples of Vivek and Rahul. So name is Vivek, and what else it is expecting? It is expecting marks. So say he got 20, and similarly student s2 equals to new student. Say this guy is Rahul, and he got 40 probably. Yeah, that's it. We have created two students. So let's check it out if this is perfectly working or not. Let's compile this. Let's run this. So yeah, it is working perfectly fine. First Vivek is getting created, then Rahul is getting created as expected. Cool. So what happens if I try to add these things? System.out.println s1 plus s2 and try to compile this. this won't even compile. Why? Bad operand types for binary operator plus. So this won't happen. Why? Because Java doesn't know what to do. How are you going to add two objects? You haven't defined it. Java doesn't even know what to do. So how can it add two objects? This is where operator overloading comes into play. But unfortunately, Java does not support operator overloading. Okay, you cannot define how to do this. Okay, see, for integers you can definitely say you have int x 10 and int y 20, and you can system dot out print ln x plus y. Do you see this? This is not an error. Java exactly knows what to do, but here Java doesn't know anything, and you cannot define anything because Java does not support operator overloading. So which language support operator overloading? Python and C++ and some other languages. So let's take the help of Python and let me demonstrate you. Again, let's create a student class in Python quickly. Let's not focus on the syntax, how I am creating the nitty-gritty details, because we are not learning Python. We are just learning what operator overloading is, and I'll show you that. For example, this is student class, and this is how we define constructor in Python. Init means initialize. Self is basically this keyword in Java. It's the same thing, but in Python we call self, not this. But you have to put it into the constructor anyway. Student will have a name, student will have marks, that's it. And you will simply assign name is to name, whatever the name the user passes, and self dot marks equals to whatever the user passes, and you just simply print that student, whatever the name is, created. Okay, simply that's it. Let's have only the constructor, let's have only this part, and let's try to create two students. So let's create student 1, say s1 is equals to student. This is how we call a constructor in Python. Don't need to define new keyword. So yeah, simply just put in the name Vivek and put in the marks. He got 20. Then say s2. Then you again create a student, say Rahul, and then say Rahul got 40. Now try to add both of them, s1 plus s2, and just print them out. Print them out. Let's save this. Will this work? Will this work in Python? Let me try Python. Example2.py. It is not working. And why so? It is simply saying unsupported operand type plus for student and student. So it is basically saying that, hey, I cannot add two student objects. I cannot add one student with another student. I cannot do this. Okay, I cannot add one student with another student. I cannot do this. Why cannot do this? Why it cannot do this? Because it doesn't know what to do. Nobody has defined, when you say one student plus another student, what to do. You haven't defined that anywhere. But we can define that. We can define that using operator overloading. I can go here into the class and I can say def add this method. Okay, this is the method. Let me just comment this thing over here. This method defines what to do when you use plus operator. Okay. And then of course you have to put this because it is a non-static method. And what are you going to take? Say for example I want something like this, that say when I add two students, I add their marks and get the average. So what is the average of Vivek and Rahul? 20 plus 40 is 60. 60 divided by 2 because there are two students. And yeah, you simply get 30, right? That's what I want. So yeah, I am basically taking another student, like the copy constructor. You remember in Java we used a copy constructor, so you will be taking another object. This is the object and you're taking another object. So what you will basically do is return whatever your mark is, whatever your marks are, plus whatever the other students marks are, add them and simply average them. How to average? Oh yeah, just divide by 2. Alright, that's it. That's it. Now can you do it? Now can you do it? Now if I save this, now if I run this, will this happen? Will this work? Yeah, this is working. So now what it is saying? It is saying student Vivek created, which is expected because he created Vivek. Then it is saying student Rahul created, which is expected. I created Rahul. Then it is showing up 30. Why 30? Because I said whatever the current student is, that is S1, and I am using the add operator. What you do? Take the other student. Take the other student. Now add both the marks. That is 20 plus 40. You get 60. Divide it by 2 and return it. So 20 plus 40, 60 divided by 2, you get 30. So this is the correct answer. Similarly, I can overload other operators as well. I can say um, def sub. So what does this do? Well, you guessed it right. You know what it does? This method defines what to do when you use minus operator. Similarly, you have mul, you have div, have all sort of things, okay, in Python. So for example, what can I do? I can simply say self dot marks. Oh, you know what? Yeah, self dot marks minus whatever the user is giving, that student's marks. I'll just deduct it, okay, and I'll return it. So similarly, I can do something like this: print s1 minus s2. This will also work now. Why? Because I have defined what to do when I'm using minus. So if I just go ahead and run this, see minus 20. Why? Minus 20, 20 minus 40. Of course, you're going to get minus 20. So it is working as well. Similarly, you can have def mul for multiplication. You can have def div for division. You can have all sort of stuffs in Python, and C++ also allows this. But unfortunately, in Java, you cannot define this. So yeah, that's pretty much it. That is operator overloading, where you define what to do when you are using some specific operator. You are defining that. That is operator overloading. This is a part of polymorphism. So defining what this operator will do is called operator overloading. Okay. All right, we are done with everything for static polymorphism. Great stuff. Now it's time to move to dynamic polymorphism, which is method overriding. Okay, let's quickly go and say this. So method overriding. What is method overriding? Method overriding simply means this. Say for example, you have a father class. Okay, this is a father class. Father class has a method called play music, which shows the name of the father and it says he is playing sitar. Okay, then you have another class called son. The son class extends the father class. It extends, basically it inherits the father class. So automatically, if I don't define this, he will do this only, right? It's better if I show you directly rather than explain here. Let me go back. What I believe is the explanation works the best. Let me just close this window. And yeah, I don't need all of these things at the moment. Let me quickly remove these things. Yeah. Oops. new class. So we have a father class and we have a son class. Son class, okay, cool. Of course, this is going to be a single inheritance. So this is the father class. And I'm not defining any properties at the moment. I just want to show you what happens. Okay, let me just have, oh, and we are of course going to use default constructor at the moment. So for example, say we have a method called public void play music. Okay, this is a simple method. Okay, we just make this a little bit bigger. Yeah, this doesn't take any argument, and it simply system.out.println and just shows playing, say, sitar, playing sitar. That's it, simply. Okay, let's save this. And maybe I have another method. Okay, maybe have, say, maybe public void eat, simply public void eat system dot out dot println eating rotis. That's it, done. We have two methods. We have a eat method, we have a play music method. Let's compile this. We are good. Let's go to sun class, remove all of these things. It will extend the father class, it will inherit from the father class. As you can see, the arrow is now drawn. So sun is extending the father class, it is inheriting the properties and attributes and methods from the father class. Say this is empty. Okay, let's compile this. Will this work? It doesn't have anything. Will this work? Yeah, it will still work. So I mean, the point is that any empty class will also get compiled. Okay, great. But just for the sake of it, let's create a method. Okay, let's say sun class also has called public void what, maybe let me think. What can sun do? I mean, sleep probably. I don't know. And it will simply say system.out.println sleeping. Okay, this is a pretty dumb method. Anyway, that's it. Okay, it has only one method. Let's compile this. I'm doing this just for the sake of completeness. I can simply remove this and compile a empty class, and that will even work. Anyway, let's go back to the entry point. This is the entry point. This is where our program starts. And yeah, let's write a program. Let's create a sun. Let's create a sun object. Sun s1 is equals to new sun. We haven't defined any constructor, so yeah, using the default constructor. s1 dot s1 dot sleep doesn't accept any parameter or something, so yeah, this works. But we can also call this method and this method. Why? Because sun has extended the father class, it has inherited the methods from father class, right? It has inherited the methods from father class, so of course we can use these two methods, right? I mean, this you have already learned in inheritance. So I can simply say s1 dot play music, s1 dot say what was that, a play music, and the other one eat. So eat. All right, let's compile this and let's run this. Let's run this. So what it is showing up, it is saying sun, like, first of all, sun is created. Of course, I'm not using any constructor, so yeah, nothing printed out there. So first of all, s1 dot sleep So the code says it will just say sleeping and you are getting it. So yeah, that's it. The next line will say s1.play music. I haven't defined it anywhere here. So of course it will fetch it from the father class, and play music will simply say playing sitar. This is expected, right? The son is playing sitar. Although this is a method from his father's class, he doesn't have this own method. Okay. Then in the third line I am saying s1.eat, and again the son doesn't have this method defined. It is extending his father, its father. The father class has this method, so yeah, it is going to show the same thing, which is eating rotis. That's it. Okay, eating rotis. This we have already looked at inheritance. So what's new here? The catch is what happens? What happens if I define the same method in the son class now? Let's try to do that. And um, and instead of playing sitar, I say something like this: playing rock guitar. What will happen now? What will happen now? This is the interesting part. Okay, if you look at it closely, if I go back to entry point was calling s1.sleep, which is okay because this was his own method, so this will show up. Entry point was also calling s1.play music. This was his this was not his own method. This was defined in his father. This was defined in the father class, and this was showing up playing sitar. But now I have defined the same play music method in his own class and have said playing rock guitar instead of playing sitar. See, I have defined the same method: play music over here, play music over here. But the difference is only this: here his father was playing sitar, and son is playing rock guitar. Okay, let's let's define this as well. Okay, or let's not define this. Let's just compile this for the moment. Compile, compile all of them. Compile, compile, and let's run this and let's see what happens. If I run this directly, what do you see now? What do you see now? s1.sleep, sleeping. This is expected. This is already defined over here. But what is not expected is this. When I am saying s1.play music, it now shows playing rock guitar. That means it is using the play music method defined in its own class. Defined in its own class. It is no longer going back to his father's class and using this method. Getting my point? It is no longer using his father's method. That's not what he is doing at the moment. Since this is already defined in here, inside his own class, he will pick this over this. He will not pick this. Why? Because the compiler already finds it into his own class. Why it would go to the parent class and find its and try to find the method? If the compiler doesn't find this method inside this class, then it will go to the parent class, that is the father class, and there it will try to find the method, and if it finds it, it will show up playing sitar. Okay, that is what polymorphism is. This is called dynamic polymorphism. This is called method overriding. I'm basically overriding the parent's method. I'm overwriting, basically overriding or overwriting. I'm overwriting the parent's method. Okay, that is why this is called overriding. Method overriding, because in originally this was the method, and I have changed the method by defining the methods in the directly in the child class or the subclass, and giving it a new different definition. That is what method overriding is. But when I am saying s1.eat, and I'm saying s1.8, it is still not there. So then it will go to the parent class, it will go here, it will try to find the eat method, it will find the eat method over here, and then you will see eating rotis. This is what this is not overridden. This method is not yet overridden. Why it is not yet overridden? Because I haven't defined it in the subclass itself. But play music method is now overridden. Why? Because I have already defined it in the subclass itself. That is why I can say this is overridden. Okay. So here's the thing. And by the way, let me just first click some screenshot so that I can explain it to you in a better way. So this is the sun class. Well, let me show you once again, by the way. One more thing I forgot to show you. What happens if I try to create a father object now? Let me delete all this at the moment. Let's create a father object. Okay. Again, default constructor. Now I'm saying father f1 dot play music. Now both of them are having the same method name, but they are calling the different methods. Okay, if I try to remove this thing and just run this. Okay, let's compile this and just run this. You know what will happen? Son is created, father is created. Okay, son plays music, it shows playing rock guitar. Why? Because inside son, the definition of play music is playing rock guitar. But when the father, for the father, I'm calling the same method called play music. But for the father, the definition of play music is playing sitar. That's why for the father, you will say playing sitar. That is the basic concept. Okay. Again, let me quickly get some pictures. This is the father class. Go back and yeah, I have to resize this image. And this is the last topic of polymorphism, and then we will be done. So this is the sun class. Okay, let's put it over here. And then we have the father class. Let's put it over here. And then let's say we have, let's go back to BlueJ. Let's have the previous implementation at the moment. Yep, let's have a previous implementation at the moment and just remove all of these things because I need to show you what's happening. Let's see how overriding happens. Okay, this is the entry point. This is of course where our program starts. So we'll start from this one. First line, we create a new sun object. Yeah, no, I haven't defined any constructor, so we will be using the default constructor. Next line, s1.sleep. Now Java compiler will try to find sleep method first in the own class, in his own class. See, this is a sun this is a sun object, this is a sun object. So Java compiler will always try to find whatever method you are putting up in his own class first before going to the parent class. So in his own class, he will try to find sleep. Is this matching? No. Is this matching? Yes. So this will get executed and you will see sleeping. So that will be the first output, sleeping. Okay, got it. What's the next line? s1.play music. So again, Java compiler will always try to search whatever method you are giving into its own class first. This is a son object, so it will try to find play music method in the son class first. Play music, it found it, so it will execute this one, playing rock guitar. So the next output would be playing rock guitar. Okay, great. What's the next? s1.8. Again, Java compiler will try to search for whatever method you given into his own class first, into the subclass first, whatever. I mean, this is a son object, so it will try to find eat method within the son class. Does this match? Nope. Does this match? Nope. So Java compiler couldn't find eat method. So it couldn't find the eat method in its own class. So now where it will search for this method? Now it will search for this method into the parent class. Come in here and now try to search for the eat method. Does this match? No. Does this match? Yes. So this will get executed. So the final output would be eating rotis. Okay. So now think about it. If this was not here, let's imagine this is not here for a moment. For this second line, what would have happened? Java compiler would try to search, not Java compiler, I'm saying it wrong every time. JVM. This is dynamic, not Java, not static. So there's no role of compiler at this moment. No role of the compiler at this moment. Okay. JVM, I'm sorry. JVM will first search for this method in its own class, which is the son class. It will try to search, and let's imagine this is not there. So there's only sleep method. So it cannot find it over here. Then it will search it in the parent class. It will come in here. Now it will find it, and you would have rather seen playing sitar. But I have made specific definition. I have explicitly defined it in the son class. Like I am already inheriting this method from father, but I'm still defining this over here. This is called method overriding, because you are getting this method from your father directly. Okay, you don't need to define this, but if you are still defining this in a different way, because originally this was playing sitar only, but if you are defining this in a different way, saying playing rock guitar or something, whatever, you are defining it. That means you are doing method overriding. Okay, that's something. Okay, let me show you one more thing so that you can understand a little bit more. Let's close this for a moment and let's create father f1 is equals to new father, and I will say two things. S1, say for example s1 dot say f1 dot play music, s1 dot play music. This is the subclass, this is the superclass. Okay, father is the superclass, son is the subclass. Let's compile this. Let's try to run this. Playing sitar, playing rock guitar. Let me click quick picture of this again. Resize it quickly. Other class. And then the student class. Sorry, the sun class. Let's see what's happening here. Okay. So first thing first, you are creating a son object, then you're creating a father object, S1 and F1 respectively. Now what you're doing, you're saying F1.play music. Now this is the father object and you are calling play music method. JVM will try to find the method in its own class first. F1 is a father object, so it will try to find play music in the father object first. Of course, it doesn't have any parent method. Father, here it finds it, this executes. So the first output would be playing sitar. Playing sitar. Okay. Okay, cool. Let's imagine the student does not have this method. Okay. Student does not have this method. Let's imagine for a moment. And then the next line is s1.play music. JVM will first try to find the method in its own class. This is S1 object. S1 object is a son object, so it will first try to find it in the son class. In the son class, let's say this, assume this is not here, it won't be able to find it here. This is not matching as well. So then it will go to the father class. In the father class, it will find again this, and you would have seen playing sitar. Same output. Okay, playing sitar for father, playing sitar for son as well. But the moment you define play music here also, like it was already defined in the super class, but if you define that in the subclass also, you are overriding this. Okay, this is called method overriding. You are overwriting the original definition. Original definition was playing sitar. Now for the subclass, you are changing it to playing rock guitar. This is called method overriding. Now this won't show up playing sitar anymore. This will rather show up playing rock guitar. This is what it will show. Okay, this is called method overriding. Now there is a catch. Listen to me very carefully. Whenever you are overriding something, try to write something like this at the gate override before the method. Why? Let's check it out. Let's come over here and let's say I do a typo over here. I do a spelling mistake over here. Let's say rather than music, I say music, something like this. Okay. And I save this. I compile this. This would compile. Did you see what happened? This would compile. But it doesn't show me that, bro, you are using the wrong spelling. It is not going to show that. It will simply think that this is just another method. That's it. This is just another method. Java compiler will simply think this is just another method. There is nothing to override and think, right? It won't say that there is a spelling mistake. I compile this, it will get compiled. Let's come to entry point. Let's try to see what happens. Let's try to see what happens. If I compile this and if I run this, if I run this, what will happen now? You are seeing playing sitar. You are seeing playing sitar for the father object, which is expected because father object has the definition of a play music as playing sitar. But for the subclass also, that is for the son class also, who has his own definition saying playing rock guitar, this simply doesn't work. This doesn't work. Why? Because of the spelling mistake. Simple spelling mistake. Java, like the Java virtual machine, the JVM, will first try to search for this method in its own class. What is the spelling here? Playmusic. It will go into the son class. It will try to search for this playmusic. This does not match. This also does not match. Where does it go to the next? It goes to the parent class. It goes to the parent class. Now it will search again playmusic. This matches. That's why even for the son class you will see playing sitar. Even for the son class you will see playing sitar, which should not have happened. This is how you get a lot of error and bugs in the code. A lot of bugs in the code if you do certain spelling mistakes and stuff. And by the way, generally when you are working in a software company, you are building software, other developers also reviews your code. It doesn't happen like this that you write a piece of code, it simply goes and runs into the server. That doesn't happen. So if you are working into a software company, what usually happens is this. This is the software engineer, this is the you, okay? This is the developer, or simply say, yeah, let's call it developer. This is you. You write Java code. A bunch of Java code. Okay. So this is the entry point. Now this is a super class. This is a subclass. Okay. You write something. This is a subclass. Now, for example, say you are overriding a method, say method X. There is a method X. You are overriding method X in the subclass. First things first, this is the server where your code is going to run. This is the server where your code is going to run. Now, in a company, you cannot just simply put the code into your server and this works. This doesn't happen. This does not happen. Also, you are not the only developer who is building this code. Maybe you are just building entry point. There is another guy who is building the subclass, maybe the superclass. There is another guy who is building the subclass. Okay, this guy is building this. You are building superclass. This guy is building the entry point. Okay, then there's another guy. This guy is called the QA. QA means quality assurance, or before just going there, let's call this guy tester. Your code will only be allowed to server once the tester tests your code, tests whatever you are passing it, tests your code. He will test it and then he will approve if they are right. If they are wrong, he will not approve. Okay, so this is the reason he cannot go in and magically check all the methods. He cannot. I mean, that is very difficult to do, right? If you are writing big Java programs, it is very difficult to go into individual classes and search which method is overriding what method, because if, say for example, if he finds some error, now he will try to search in this class also, is this overriding something? Okay, what is it overriding? Where is it overriding? And so many things. So just to avoid confusion and stuff, the first thing first that you need to do is whenever you're overriding a method, just say that, hey, I am override. Just do this. This means overriding method. Just write this. This will serve two purpose. First thing, say for example, this guy, or for example, say this guy views this code, he will immediately know that this method is overridden. He will immediately know. Why? Because he will see this thing called @override. He will see this. Okay, this doesn't work in Blue or what? Oh, my bad. I have to write it like this, override, like this. Yeah, now this works. So the moment some developer sees this thing, he will immediately know that this method is basically overriding the parent class's method. Immediately he will get to know that this method is overriding the parent class's method. This is the first use case. People will know this. And by the way, this is called annotation. What we call this, we write this. Whenever you see this symbol in Java, it basically means annotation. Why do we use this? Two reasons. First reason is to let others, who are others? Other developers, other devs, basically other developers, testers, quality assurance guys, whatever. I mean, there are a lot of guys in engineering department, to let others know something, to let others know, or to notify others, or to let others know about something, about what's going on. And the second reason, strict compiler check. What does this mean? We'll look it in a moment. So this is called annotation. There are many different types of annotations. Let me give you some of the examples in Java. Let me quickly think about it. So yeah, there can be a few. Say the first thing that, or the thing that we're already using is this one, override. This means the method is overriding the parent class's method. This basically means, but there are many. For example, there can be something called something as the deprecated, to show that the method is no longer used, or this is the old way, or something like this. There can be many more. There can be something as suppress warnings, and there can be a lot. Okay, suppress warnings and all. But for now, you need to understand only this override. This basically means the method is getting overridden. It is basically overriding the parent class's method. That's it. That's all you need to understand for the moment. There is another purpose. There's another purpose for using @override annotation over here. See, if I write a spelling mistake, say MUSIK, and I try to save this, do you see? Immediately a red line appears. What does it say? It says method does not override. I mean, Java compiler says that, okay, you're telling me that you are overriding a method, right? But what are you overriding? You are saying the method's name is play music, MUZIK, but I cannot find this method into the superclass. I cannot go into father and find this method. I cannot see MUSIK. I cannot see MUSIK. So basically, this also prevents errors. Okay, this won't even let you compile if you do some spelling mistake. It won't even let you compile. What does it say? Method does not override or implement a method from the super type. Basically, simply it is saying there is a spelling mistake because it cannot find this. See, you will only override something that exists in the parent class, right? You cannot override something that does not exist in the parent class. You can only override something that exists in the parent class. You are saying that, hey, I am overriding this method, but you are saying the name of the method is PLAYMUZIK, and you can only override something that already exists in the parent class. MUZIK does not exist in the parent class, so it immediately says that there is a problem. Your method is not overriding anything, so there's a spelling mistake or some other issue, or maybe you are confusing with something. So this is another thing that it serves. So whenever you are overriding, do use this thing. This is the override annotation, and remember to put the O as capital. Okay, O will be capital. This is how it works. And the moment I do something like this, MUSIC, now it compiles perfectly. Why? I can only override something that exists in the parent class. I'm saying I'm overriding this method. The name of the method is PLAYMUSIC. It tries to, the compiler tries, actually it goes into the father class and it tries to see that play music exists. Only if play music exists, only then it will let me compile. If I use some other method, say for example play mew or something like this, it will not let me compile. It will not even let me compile. Why? The Java compiler will actually go into father. It will try to search play moo. It doesn't have any play moo method. It will not let me compile. So it will prevent spelling mistakes. That is another use case. So whenever you're overriding, yes, you can ignore this, but the best practice would be to use annotation, and in the future videos I will be using annotations as well. So yeah, that's basically it. Let me compile this and we just remove this, again compile this, and let's run this, and it works as expected. So basically for the father object you are still using this thing, of course, but for the son you are overriding the play music method, and you are basically using your own implementation, which is playing a rock guitar. Also, how do you override this method, eat method? How do you override it? We can say override, we can say public void eat, and simply you can say system.out.println, and we can say eating pizza. Okay, so we have overwritten it. Now if I try to go to entry point and again f1.eat, this is a father class, and I can say s1.eat, This is the son class. I compile this, try to run this. Now see what's happening. Father is eating rotis, son is eating pizza. Son is eating pizza because I have overridden. Because if this was not there, of course, son would have also eaten rotis. But since I have explicitly defined it, what to do when son eating pizza, I have explicitly defined the eat method for the son class. But there's a little bit of problem with this approach, That little bit of problem is that, say for example, you want to put an argument over here, say a parameter over here. I can say string food. This will not let me compile anymore. Why? Because this annotation will basically go into the father class and check for the signature of eat method. Now in this case, the name is same, of course, but the problem is that it does not accept any parameters over here. So Java compiler also expects that this overwritten method will also not accept any parameter. That is the problem. If this does not accept any parameters, this should not accept any parameters as well. That is the problem with this annotation. So in this case, if you just override it, if you just delete this thing, compile this and compile this, let me just go here and say s1.eat burger, and over here just say eating. Rather than eating pizza, I would say eating whatever the user gives in. Save this, compile this and run this. Compile this, and yeah, just remove this and run this. So you can see eating rotis and finally eating burger as well. Okay, this is how you can do it. So this is method overriding. But um there's something that I want to show you. Can you combine method overloading and method overriding? Can you do that? Let's try. Can we say something like this? Public void eat without any parameters, of course. System.out.println eating pizza. What is this? Is this method overriding or is this method overloading? Answer is it is both. For the son class, this both together is basically method overloading. Why? This accepts no parameter, this accepts only one string parameter, but both has the same name. That means this is method overloading. But for the father and son relationship, this basically means method overriding, because the original method, and also of course, since this matches the signature, I would rather use override. If this matches the signature, just use the override annotation. Okay, it's better. If it doesn't match the uh like literally the signature of the parent class, for example, in parent class it was not accepting any parameters, but in son class it is accepting any parameters, so you cannot use override annotation. But if in parent class it was not accepting any parameters, and in student class also, sorry, the son class also, it is not accepting any parameters, then it matches the signature and you can use the override annotation. Okay, so what is this? Is this overriding or is this overloading? So in the context of son class, yes, this is method overloading. Both the methods having the same name but different list of parameters, of course. But in the father son relationship, this is method overriding. Why? Because the original method of eat was this, eating rotis, but son has slightly different approach, its own implementation, having the same method name, which was his parents, which was already existing in his parents class, but with a different implementation, that is eating pizza. That's why this is overriding as well. And when you combine both of them, in context of the Sun class, this is method overloading as well. Why? Because this is also it, this is also it, this is accepting different set of parameters, this is accepting no parameters, but both has the same name. So this is method overloading, not overriding. But in relationship of father and son, yes, this is overriding, not overloading. Okay, so that's how you can combine different things of polymorphism. You can have constructor overloading and all that stuff, right? You can combine, you can bind these things, you can merge these things, and you can play around with these things. Okay, yeah, okay, cool. Final thing, why static, why dynamic? Why do we call all of these things as static? Because in static, what are the types of static polymorphism? Constructor loading, method overloading, operator overloading. Why do we call them static? Because compiler knows which method will be triggered during compilation. And why is this called dynamic? What is dynamic polymorphism? Simply method overriding. This is dynamic. And why is this dynamic? Because compiler does not know which method, and by which method I mean the parent's method or the child's method, will be triggered. So basically this means this thing, static polymorphism, happens in Java. What is Java? Java compiler. Dynamic polymorphism happens during runtime. And where does Java code run? JVM. So dynamic polymorphism happens inside JVM while the code is running. Static polymorphism, I mean, this happens within the Java compiler. The moment you compile this, the compiler already knows which method is going to be triggered. That's why it is static. But here the compiler does not know which method, I mean, the parent's method or the child's method will be triggered. It doesn't know about it. Okay. Yes, it does check. It does check when you are using that override thing. I mean, when you are using the annotation override, you might say, hey, Java knows. No, Java doesn't know. All Java compiler knows is that this is overriding its parent's class's method, but it doesn't know that during runtime, when the program is actually running and I'm calling this method, say f1.eat, say for example s1.eat, s1.eat, Java compiler doesn't know whether this will trigger this or this will trigger this. That Java compiler doesn't know. Java compiler only uses annotation to verify that there is no spelling mistake while overriding. That is the only work of override annotation. Okay, it just tries to check that yes, eat method exists in the parent class also, and yes, you are overriding it. It just verifies it. It just verifies this override annotation used for only for that only, not not that the Java compiler knows which method is going to trigger. So that's why this is called dynamic polymorphism. And that's it. And I will give you ample examples, a lot of examples of method overriding, method overloading, operator overloading, so many things in the upcoming videos. So thank you so much for watching. See you in the next video where we will be covering probably packages or maybe abstract classes or something. We'll see about it. Thank you for watching. Bye bye.